It feels like every single week there's a new AI model that just completely shatters our expectations of what's possible. The pace is absolutely incredible. But with all this change happening so fast, it's really easy to lose track of the big picture. So let's take a breath. We're going to dive in and get a clear, evidence-based look at where AI stands today, the very real risks that come with all its power, and how we're trying to build a safer path forward.
Here's our game plan. We're going to start broad with a kind of report card on AI's current skills. Then we'll funnel down to look at the risks that come with those skills. From there, we'll do a really deep dive into a fascinating discovery about AI and morality. And then we'll zoom back out to see how this tech is actually being put to work. And finally, look at the big strategies for trying to manage this whole thing.
Okay, so to ground this whole conversation, we're pulling a lot from the latest International AI Safety Report. Now, this isn't just some random paper. It's a massive global effort with over 100 AI experts, and it gives us this fantastic evidence-based snapshot of what these systems can really do right now.
So what's the engine behind this AI explosion? Well, it all comes down to one thing: compute. The sheer amount of processing power being thrown at these models has been growing exponentially. We're talking about a measure called flops, and the numbers have 26 zeros after them. I mean, just try to picture that. This colossal scale is what lets these models learn from these huge data sets and develop their incredible abilities.
And the results? They're pretty impressive. Today's AI can write complex code, create mind-blowing art, and even help scientists discover new drugs. But the real game changer is how they're starting to think. We're seeing the rise of these so-called reasoning models. So instead of just spitting out a single answer, they actually work through a problem, generate a few different possibilities, and then pick the best one. It's like they're showing their work. And that approach is leading to huge leaps in performance on really tough problems.
But let's not get ahead of ourselves here. For all its power, AI is still really, really uneven. The report makes it super clear that these systems can be unreliable, especially when a task has a lot of steps. They still hallucinate, they just make things up. And, crucially, their understanding of the real physical world is pretty limited. Plus, their performance takes a nosedive when they run into languages and cultural contexts they weren't extensively trained on.
And this exact combination, this mix of incredible power on one hand and, uneven reliability on the other, that's where the risks really start to pop up. A tool this potent was always going to have a dark side, and getting a handle on that is absolutely critical. The AI Safety Report gives us a really helpful way to think about this, breaking the risks down into three main buckets. First, you've got people intentionally using AI for bad stuff. Think scams or cyber attacks. Second, you've got the systems themselves just failing or acting weird. And then third, you have the bigger, slower-moving societal impacts that come from just deploying this tech everywhere. This here perfectly illustrates the dual-use problem. It's the classic double-edged sword. The very same AI capability can be used for good or for evil. An AI that's brilliant at finding software flaws, it can be a cybersecurity team's best friend or a hacker's most powerful weapon. And that's a huge challenge, right? Because you can't easily ban the harmful uses without also hurting the beneficial ones. And beyond the bad guys, there are risks just baked into the technology itself. We already talked about hallucinations, but just imagine that in the context of getting medical advice or building a critical piece of code. The report also points to a more future-facing concern, the idea of just losing control of a super-capable system. And maybe the most immediate risk of all is something called automation bias. That's our very human tendency to just trust what the computer says, even when it's subtly or catastrophically wrong.
And this quote just brilliantly sums up the core dilemma. The technology is like a speeding train, but our understanding of the risks and how to fix them is like trying to lay the track just a few feet ahead of it. If you act too soon, you might stifle all the good things. But if you wait for perfect evidence, it could be too late.
This whole challenge of managing risk leads us to a deeper, more fundamental question. As we make these AIs more and more powerful, what's actually happening to their internal values? So let's funnel down from those broad risks to a really specific and, frankly, fascinating area of research: AI's moral compass. This really is the big question, isn't it? I mean, it's one thing to teach a machine to play a game or write a sonnet. It's something else entirely to expect it to have a moral compass. But some new research suggests something truly strange, and maybe even profound, is happening as these models just get bigger. Okay, first, a quick definition so we're all on the same page. In the world of AI, a scaling law is basically a predictable relationship. It says that as you add more compute and more data, as you scale the model up, its performance on a specific task gets better in a surprisingly consistent way. We've seen this for language, for coding, but does it apply to something as fuzzy as morality?
So get ready for this, because this chart is the jaw-dropping result from a huge study of 75 different AI models. They were all tested on those famous moral machine dilemmas, the tricky self-driving car scenarios. Okay, so on the bottom, you have model size, getting bigger as you go to the right. And on the side, you have how different its choices are from human moral judgments, so lower is better. And just look at that trend. It's not a perfect straight line, but there is a clear, consistent pattern. The bigger the model, the more its ethical choices align with ours. Let that sink in for a second. Think about what this implies. No one is explicitly programming these models with philosophy textbooks. It seems that just by training them on massive amounts of human writing, a human-like moral intuition just emerges. It's a spontaneous side effect of getting bigger and smarter. And that is a truly wild idea. But wait, there's more. The researchers dug deeper, and they found another layer to this. It's not just about raw size. The actual architecture of the model, like how it's designed to process information, plays a huge role too. Remember those reasoning models we talked about earlier? Well, it turns out they have a serious edge here.
And this is the key finding. Models that are built to think through a problem, step by step, show significantly better moral alignment than standard models of the same size. And what's fascinating is that this advantage is biggest in the smaller models. It suggests that better reasoning can act as a kind of shortcut to the moral alignment you'd otherwise only get from massive, massive scale.
Okay, so we have these AI models that are getting more capable and, surprisingly, more morally aligned. Now let's zoom back out and see how this is changing the way AI is actually being used in the real world. We're moving way beyond simple chatbots to something far more powerful.
I want you to meet agentic AI. If generative AI like ChatGPT is a tool that responds to your prompts, think of agentic AI as an autonomous employee. You give it a high-level goal, and it breaks that goal down into steps, uses different tools and systems to get those steps done, and adapts as it goes. The key thing to understand here is the shift from just responding to actually taking initiative. And this isn't sci-fi, it's already happening. In customer service, an AI agent can spot a shipping error, automatically issue a refund, and notify the customer. No human has to get involved. In a supply chain, an agent can see a storm is about to close a port and just automatically reroute shipments. In cybersecurity, it can detect a threat and immediately isolate the affected computer. The big change here isn't just about doing things faster. It's about delegating entire decision-making loops to a machine. Which brings us to our final and maybe most important question. How on earth do we manage all this technology safely? Well, the AI Safety Report offers a pretty clear strategy. The report champions an approach called defense in depth. The core idea is simple. No single safety measure is perfect. So you layer them. It's like having multiple lines of defense. You start by thinking about threats, you rigorously test what a model can do before you release it, you build in technical guardrails, you monitor it out in the wild, and you have a plan for when things inevitably go wrong. Each layer is another chance to catch a failure before it causes real harm. But technical fixes can only get you so far. The report really stresses that we also need to build societal resilience. This means things like training people to spot AI-generated deepfakes, creating tools to trace where content actually came from, and finding ways to align AI with a diverse range of human values, not just the values of a small group of programmers. It's really about making society as a whole more adaptable and robust in the face of this transformative technology. And that, really, leaves us with the ultimate question. The scaling laws for AI's capabilities are clear, and they are relentless. But there is no predictable scaling law for the growth of human wisdom. As these two curves continue their journey, the gap between them, well, that's what's going to define the biggest challenges and the biggest opportunities of our time.